We're going to go over the problems from the derivative 4. Problem number 1. Compute the limit as h approaches 0, tangent x plus h minus tangent x all over h. Now, this is the definition of the derivative, right? And what function are you taking the derivative of? That one right there, tangent x. So if you remember what happened on a previous worksheet, the derivative of tangent x is secant squared x. So you write it down and you're done. Now what happens if you can't remember that? Then you gotta reinvent the wheel. Tangent is sine over cosine. So to compute the derivative of that, you have to use the quotient rule. Low d high, which is cosine x, minus high d low, which is negative sine x, all over denominator squared we go. And then that's going to be cosine squared x plus sine squared x all over cosine squared x. And then the numerator, you somebody, that's 1. And that's how you get secant squared x. Oh, so it kind of pays to remember things. Yeah. Ooh, nice. And then problem B is another definition of the derivative. You're taking the derivative of cosine x, which we know is negative sine x. Boom, finished. C, you're taking the derivative of e to the x, so the answer is e to the x. That's money. 2, f of x is equal to sine x plus cosine x. When is the derivative negative, less than 0? So the first thing we need to do is compute the derivative, which is cosine x minus sine x. Now, when is this negative? We need to make a number line. Now, it's already, can't really factor that already, so we have to leave it like that. So now we got to think, when is cosine x equal to sine x? Well, pi over 4 and 5 pi over 4, right? Because they're both, at pi over 4, they're both root 2 over 2, but at 5 pi over 4, they're both negative root 2 over 2. And if you don't like that explanation, how about divide both sides by cosine x? So you will get 1 equal tangent x. When is tangent x equal to 1? Duh, pi over 4 and 5 pi over 4. Then, and remember, when you're testing a number line for trig functions, there is no pattern, so you have to do each one. So if you plug in a number smaller than pi over 4, like 0, into the derivative now, you will get 1 minus 0, that's positive. Plug in something between pi over 4 and 5 pi over 4, say pi over 2, you get 0 minus 1, which is negative. And then, of course, if you plug in 0 and 2 pi, you should get the same thing, so that's positive. And so we're looking for negative, so that would be between pi over 4 and 5 pi over 4. Easy money. Next, number 3. If you are given the derivative of a function, in this case 1 over root x, what was the original function? Well, first change it to x to the negative half. Now remember, when you take a derivative, you have to put the power in the front and reduce the power by 1. So that means if we're going the other way, we have to increase the power by 1. So negative 1/2 plus 1 is 1/2. And then when you put the 1/2 in the front, we need to get a 1, so that means you need to have the reciprocal of that there, which is 2. And don't forget to put plus constant, because the derivative of any constant is 0. And don't forget to put the plus c, because that's going to cost you at least 1 point if you don't put the plus c. Number 4, find the x-intercept of the line that is tangent to the graph of y equals x cubed minus x minus 1 at the point when x is 1. Now, what are the two things you need to write an equation of a line. You need a point, and then you need the slope. Well, the x-coordinate is given. To figure out the y-coordinate, you simply plug it into the original function, and you get 1 minus 1 minus 1. That would be negative 1. To compute the slope, you need the derivative. The derivative is 3x squared minus 1. So at this particular point, when I plug in 1 for x, now it's not the slope until you actually plug in the x-coordinate into there, you will get 3 minus 1, which is 2. So now that I have a point and a slope, I can use point-slope form. Y plus 1 equal 2 times x minus 1. But we're not done because it says find the x-intercept of this line. So how do you find the x-intercept of any graph? You substitute 0 for y and solve for x. Well, divide both sides by 2. 1/2 equal x minus 1. Add 1 to both sides. X equal 3/2. Pukui. Child's play. Number 4. No, number 5, fool. I'm not going to write this function down. You have it there. When is the second derivative greater than 0? So what we need to do is find the second derivative. So first derivative is 5x to the 4th minus 30x squared. I'm smelling synthetic division here. Minus 40x plus 2, 3, 5, 7 plus 0. The second derivative then is 20x cubed minus 60x minus 40 plus 0. Remember, the derivative of any constant is 0. Factor out of 20. X cubed minus 3x minus 2. So how do we factor that? It looks like synthetic division. So 1, 0, negative 3, negative 2. Don't forget to put the 0. So factors of 2 over factors of 1. So it's either plus or minus 1 or plus or minus 2. And you can clearly see that 1 doesn't work. So the next logical choice would be to try 2. So 1, 2, 2, 4, 1, 2, 0. It works. So one of the factors is going to be x minus the number in the box. Please put minus. And the other factor comes from this, which stands for x squared plus 2x plus 1. That factors some more. That's x plus 1 quantity squared. So now everything is factored. We can make a number line. Negative 1 and 2 go on the number line. Plug in a number bigger than 2, say 3. So you would get 20 times positive, which is positive. And then it's going to change to negative here because 2 came from this factor, but that has an odd power, right? Negative 1 came from this factor. It has an even power, so it's going to stay the same. So what was the question? When is the second derivative positive? Well, obviously when x is greater than 2. Kaboom! Synthetic division is fun. Number 6. The normal. Now remember, normal means perpendicular to the tangent line. The normal line to the curve, y equals 4x minus x squared, at the point 1, 3, intersects the curve at what other point? Oh, I even told you what the normal line is because some of you might have forgotten. Well, let's draw a picture to see what's going on. This is a parabola, right? Opening downward. And then at the point 1, 3, maybe we need to draw it a little more accurately. Oh, this is terrible. Because if you factor this, you get x times 4 minus x. The x-intercepts are 0 and 4, right? And at the point 1, 3, that would be about there. This is the tangent line. The normal line will be perpendicular to that, like this. Can you see that it intersects the graph at another point? That's what we need to find. Well, how do you write the equation of the normal line? Well, first we need a point, which is given. Then we need a slope. So we need to take the derivative because the derivative tells you the slope. The derivative of 4x minus x squared is 4 minus 2x. At the point 1, 3, when I plug in 1 for x right there, the slope comes out to 4 minus 2 times 1, which is 2. So if this is the slope of the tangent line, the slope of the normal line will be the negative reciprocal of that, negative half. And if it passes through the point 1, 3, again, we can do point slope form. Y minus 3 equal negative half times x minus 1. So here's the equation of the normal line. Here is the equation of the line. So how do I figure out where they intersect? It's called substitution. If y equals 4x minus x squared, I can take that and substitute it right there. So you get 4x minus x squared minus 3 equals negative 1/2 times x minus 1. First thing I would do, multiply both sides by negative 2. So you would get negative 8x plus 2x squared plus 6 equal x minus 1. And what a surprise. It's a quadratic equation. So 2x squared minus 9x plus 7 equals 0. Factor it. 2x and x. 7 and 1 minus minus. So x equals either 7 halves or 1. Now we already knew that one because look, the graph already, we can clearly see that this line, right, already intersects the graph at 1. We want the other one. That would be this one right here. So if the x coordinate is 7 halves, how do you find the y coordinate? Well, you can either plug it into the line equation or the parabola equation. Which one looks easier? I don't know. Maybe the line equation in this one, right? So y equals negative half times 7 halves minus 1 plus 3. So what would that be? Y equal negative half. What is 7 halves minus 1? 5 halves plus 3, which is negative 5/4 plus 3, which is 12/4. So then you get 7/4. Kaboom! I think we'll be seeing that one on the test. Number 7. F of x is given, looks like a power series. What is the derivative? I'm not going to write the original problem. So taking the derivative term by term, you will get 0 minus x plus 1/3 x cubed minus 1/5 x to the 5th plus 1/7 x to the 7th minus ... Hey, you almost somebody. If I factor out the negative sign, hey, you somebody. What is that? That's this here. That's the power series for something. We know that one. 10 inverse x, baby. Number 8. If f of x is sine x, compute the 2357th derivative. Well, obviously, there's going to be a pattern, right? So let's do the first derivative. What's the first derivative? Cosine x. Second derivative is negative sine x. Third derivative is negative cosine x. Fourth derivative is sine x. And then the fifth derivative is going to be cosine x. So what's happening is it repeats every 4. So how do you find the 2357th derivative if it repeats every 4? You divide by 4 and look at the remainder. So 4 goes into 23 5 times, right? Remainder 3. 4 goes into 35 8 times, remainder 3. 4 goes into 37 9 times, remainder 1. So what's the answer? Ka-two! Cosine x. Let's see, can we squeeze this problem in? Nope. Number 9. F of x is equal to sine squared x minus sine x between 0 and 2 pi for when values of x is the derivative equal to 0. Come on! So, first of all, sine squared x is the same thing as sine x times sine x. Now, you can factor that or you can just leave it like that. Either way, you're going to have to use the product rule. Now, right here, I see a product. So, how do I compute the derivative? Make up my own, or should I use the product rule? Duh. Derivative of the first, leave the second one alone. Now you leave the first one alone, derivative of the second. And then don't forget to take the derivative of this baby, which is cosine x. So what do I got here? I got 2 cosine x sine x minus cosine x. I can factor out a cosine x, which is 2 sine x minus 1. Now I don't even have to make a number line because I just want to know when it's equal to 0. Don't worry, on the test it'll be less than or greater than. So when is cosine x equal to 0? Pi over 2, 3 pi over 2. What about this one? When is sine x equal to 1/2? Pi over 6, 5 pi over 6. Fini! Okay, number 10, we're going to need more room because I can see already. We're going to have to use the quotient rule here. So number 10, f of x is equal to x over x squared plus 1. When is the second derivative equal to 0? So first derivative is, now I see a quotient, so you need to use the quotient rule. So low d high, which is 1, minus high d low, which is 2x, all over denominator squared we go. So if we multiply out the top, you got x squared plus 1 minus 2x squared all over x squared plus 1 squared, which is 1 minus x squared over x squared plus 1 squared. Hello. I'm recording a video. Now we need the second derivative. The second derivative is, now again, we still have a quotient, so we got to use the quotient rule. So low d high minus high d low. Now look at the denominator there. How do we take the derivative of that? Well, what we know right now, we just have to multiply it out. So that would be x to the 4th plus 2x squared plus 1. So to take the derivative of that, that would be 4x cubed plus 4x. All over denominator squared we go. So that's going to be 4th power. Now, to figure out when this is equal to 0, that would be when the numerator is equal to 0. So what we need to do is we need to factor the numerator. So probably what you should do is factor that. You can factor out a 4x and you get x squared plus 1. So instead of multiplying out everything, you probably want to factor now. What can be factored out? Looks like you can factor out a 2x and an x squared plus 1. What's going to be left? Negative x squared plus 1 minus 1 minus x squared times 2. Yep, x squared plus 1 to the 4th. This cancels into that 3 times. So we need to simplify what's in the brackets. We're running out of room here. We're going to have to go up here. So equal 2x times. So if I simplify what's in the brackets, you're going to have negative x squared minus 1 minus 2 plus 2x squared Goof! All over x squared plus 1 cubed. Wow, then we're going to have to go up here. We got 2x times x squared minus 3 all over x squared plus 1 cubed. So when is this equal to 0? Well, when the numerator is 0. What will make that 0? Duh. 0 and plus or minus root 3. Ka-ching! Last problem. Number 11. OU. Number 11. F of x is x e to the x. When is the second derivative equal to 0? Well, first we compute the first derivative. And again, I see a product. You must use the product rule. Derivative of the first, leave the second one alone. Leave the first one alone. Derivative of the second. Factor out of e to the x, you get 1 plus x. And then again, I see a product. You must use the product rule. Derivative of the first, leave the second one alone. Plus, leave the first one alone, the derivative of the second. Factor out of e to the x, and you get 1 plus x plus 1 e to the x times x plus 2. So when is this equal to 0? Obviously when this is 0, so x equals negative 2. And again, remember, e to the x is always positive. Fini!